Hey guys, in this session we're going to be looking at comparing fractions just to kind of figure out which one is bigger and which one is smaller. So I've given out three examples here and just to kind of try different varieties of questions. So we're going to get started with the first question. Looking at the first question, this is question A we're talking about. We've actually got 3/7 or 5/7 and you're trying to figure out which one is actually bigger. And I guess for us to do this, I'm going to kind of go back a little bit into just numbers. And I'm going to ask you this question here first, right? So I'm going to go use a different color here. So if I actually ask you what is bigger, 30 or 50, you would actually say it's 50, all right? And the reason is, well, you just know it, right? Because it's like, well, 50 is bigger than 30. Well, how do we define this really? Well, we do know that 30 could be broken down as 3 tens, and then 50 could be broken down as 5 tens. And if you think about it, what we really have done here is we've kind of grouped them in tens. And on the right-hand side, we've actually got three groups of 10. And sorry, on the left-hand side, we've got three groups of 10. And the right-hand side, we've got five groups of 10. So we know that 5 is bigger than 3. So likewise, when we are actually dealing with fractions, what we've got here is 3/7 and 5/7. So why don't we actually write it down in an English, like in words? All right, so what do I mean by that? We write it down like this: 3/7 and we've got 5/7. And if I was to follow the same principle that I did with the tens, I know that 5 tens is bigger than 3 tens. Likewise, in this case, I could actually say 5/7 is bigger than 3/7. All right, now, and I know that if you guys have actually been watching some of the videos previously, I did talk about the greater than or less than symbol, how to use this. And I'm going to show you guys, and I'm going to see if I can link that somewhere. Hopefully, that should be popping up somewhere, hopefully. But yeah, 5/7 and 3/7. How do we actually write this with a greater than or less than symbol? Now, you could have done your first answer like this, because we said 5/7 is greater than 5/7 is more than 3/7. So because it's more than, we could write the symbol where it's greater than, like this. But if we want to keep that original statement as it is, then we could have actually written it as 3/7 is less than 5/7, which actually means we're going to get 3/7 and 5/7, and because it's less than, we're going to use this symbol here. And again, as I said to you guys, there's a video that I'll see if I can put it in the description. There's a link for using the greater than or less than symbol, but pretty much that's the idea. So when we're comparing fractions, we want to make sure that the denominators are the same. And if they're not the same, like in question B, we'll have to figure out a way to make them same. So let's go to question B right now. And if you look at it, we've actually got two different denominators. One, we've got 5 here. The second denominator happens to be 20. So what we need to do is we actually need to convert the 5 into a 20. And if you go back in this series, I've done some work on equivalent fractions. That is fractions where you can write it in multiple different ways, but they still have that same, which equals to the same fraction. So in this case, I've got 2/5, and what I really want is I want that denominator to be 20. So I have to look at this. What number am I multiplying by 5 to get to 20? So in this case, it's actually going to equal 4. So remember that with fractions, whenever you do something to the denominator, you also have to do the same thing to the numerator. So I've actually got to multiply 2 by 4 as well. Now in this particular case, what's happening is 2 times 4 is going to be 8. And what we actually have in this case is we've got 8/20, and we also got 8/20. I mean, unfortunately, in this case, both of these fractions are actually equal to each other. So we could actually say 2/5 is actually equal to 8/20. So there's no greater than or less than symbol at all. All right. Hopefully that made sense. Let's go to question C. Question C is we've got 4/7 and 3/5. Now here's where things start getting a little bit tricky, because A, you're looking at question B and go, well, I know what to do to 5 to get to 20, but 7 and 5, that's a bit tricky, isn't it? Well, not really. All right, the best way to do this is what we call multiples, right? And don't worry, guys, I'm going to cover this some more in the upcoming few levels. So this is just to kind of what do you call it? Just a little bit of a reminder of what's possible with fractions. So what I'm going to do is I'm actually going to write down all the multiples of 5. All right, what do I mean by multiples? I'm talking about all the times tables, the end results. So that's 5, and then I've got 10, I've got 15, 20, 25, 30, 35, and really I could just keep going on. But the real aim of this experiment is knowing when to actually stop, because I got to do that for 7 as well. And I'm looking for the 7 times tables. I'm looking for a number that's going to be common in both of these lines. All right, and I'm sure you guys have picked it up that 35 is going to be the number that we're looking at. So in other words, what we have to do is we have to change this 7 into a 35, and we've also got to change this 5 into a 35. So let's do that here. I'm going to put down 4 over 7, and I want this equivalent so that the denominator is actually 35. So that's for the 4 over 7. And I've got to do the same for the 3 over 5. And I've got 3 over 5, and I've got to somehow manipulate the denominator so that I get 35 as the denominator when I do equivalent fractions. And it's kind of simple. You go, okay, it's 7 times 5 is 35, so I've got to go 4 times 5 as well in the numerator. So which means 4 times 5 is equal to 20. And on this side, I've got 3 over 5. So 3 over 5, I know that I've got to multiply 7 to the denominator and also 7 to the numerator. And what I've got is 3 times 7 is equal to 21. So what I'm left here with is my two fractions are now changed into equivalent fractions. I've got 20 over 35, and then on this side I've got 21 over 35. And if we go back to what we did in question A, we looked at it as, in this case, it would be 20 35ths and 21 35ths. And we know that 21 35ths is bigger than 20 35ths, or we could say 20 35ths is less than 21 35ths. And that's pretty much the generic idea behind comparing fractions, guys. It is always to look at the denominator and see if you can bring the denominators to the same number. When you bring the denominators to be same, then comparing numerators is pretty much straightforward. It's like trying to find out which number is bigger. That's it. Anyway, guys, that is basically it for this little video here. As always, thank you for watching, and follow the series to learn more. Thanks again.